Welcome to another Back of the Net recording. This one is about direct proportion problems. The thing that's sometimes hard about these is identifying the actual question and knowing that's the technique to use. I read the question first of all to lead us into it. So a car uses 9 litres of petrol to travel 126 kilometres. How far will it travel on 5 litres of petrol? Now the crucial bit about these is often you're given a fact and then you're given a question. So I just undo the highlighting a minute and say that again. So we get given a fact: a car uses 9 litres of petrol to travel 126 kilometres, and then we're given a question: how far will it travel on 5 litres of petrol? And normally it's that second bit that is repeated: travel on 5 litres of petrol. So 9 litres of petrol, 5 litres of petrol. And when you can match those two up, that often is the key to using this technique. The technique we're going to use for this is called going through one. You don't need to really know that, but it's one that your teacher may have spoken to you about. I quite simply write down the information I'm given in the question. A car uses 9 litres of petrol to travel 126 kilometres. And the trick here is to write 1 in the middle, and this is why we call it going through 1. How do we get from 9 to 1? Well, we divide by 9. How do we get from 1 to 126? Well, we times by 126. So how do we make the whole journey? Well, we divide by 9 and then we times by 126. And we can write that as a machine chain, which is something we use quite often. We'll also use it in solving equations. So it's a technique I like students being familiar with because it's useful in many circumstances. So now I know I can put my petrol in. I divide it by 9. I then times it by 126, and it will give out to me my distance in kilometres. So that's the rule that links the petrol to the distance, and it will work for any combination of numbers within this question. So I've set the question out. The facts from here in that first bit are now written in a mathematical form that I can use to answer the question in the second bit. So I now know I have 5 litres of petrol. So all I have to do is feed 5 into there. So it's 5 divided by 9 times by 126 will give out the distance I have to go. Now I'm going to use a calculator for that. So 5 divided by 9 is 5/9, which is 0.55 recurring. I'm going to leave it in my calculator as that recurring decimal. I'm then going to times that by 126, and I've got an answer of 69.4 recurring. Now 9 and 5, comparing the amounts of petrol I start with, that's just a bit more than half of what I originally had there, so I should be going just a bit more than half of 126. Well, a half of 120 is going to be 60 kilometres, so 69 kilometres looks pretty good to me. I'm happy for that being an answer. Probably a 2-mark question. You'll be getting 1 mark for having the answer, but you'll also be getting a mark for knowing that it's divided by 9 times 126. So just to recap, look at the question, identify the fact, look for the question bit of the question, if that makes sense, look for the repeats, When you've done that, use going through 1, write it out as a machine chain rule, and then answer your question as I've done there. Here's one for you to try. Press pause. Welcome back. Okay. Here we go. 15 boxes of cereal weigh 5 kilograms, 625 grams. What will 4 boxes weigh? So I've straight away fact, then question. I'm now going to look for the commonalities. Boxes of cereal weigh. Boxes of cereal weigh, and boxes of cereal weigh. So just from the text there, I'm able to have a go at this question and thinking it's that one where I have to find one amount from the other amount, and I'm going to use going through 1, going through 1, GTO going through 1. Start my question. First of all, 15, so I do it in black so that we know that's a given fact. 15 gives you 5 kilograms, 625. So I'm going to put 625, and I'm working in kilograms. 5.625 kilograms. I'm going to go through 1, so I need to divide by 15 times by 5.625. Write that as a machine rule. First bit, and then there's a second stage. First bit was divide by 15 and then times by 5.625, and that was my boxes going in, and out came the weight. I now put in the information particular to my question bit, and here it was, what will 4 boxes of cereal weigh? So I'm going to start with 4, divide by 15, and then times by 5.625, and again I'm going to use my calculator. So 4 divided by 15 is 4/15, which is 0.26 recurring. I'm going to keep the number in my calculator and then just times that by 5.625, and that's come out as 1.5. Don't forget to write the kilograms. 1.5 kilograms. I can do that estimating thing again. 15, well, it's about 4's just below a third of that, isn't it? So a third of that looks about right to me. Seems to right. It's certainly not more than 5 kilograms, so I'm probably right. Okay, similar question. Let's highlight it again to get used to that technique of highlighting the question we need. Mercury orbits the Sun 4 times in 352 days. That's the fact. And now this is a question. The other colour pen. The question is, how many days will it take to orbit the Sun 7 times? And again, we can do that bit of identifying orbits the Sun. There we go. 4 times orbit the Sun 7 times. So that repeating the phrase in the fact and the question is a link to this technique. So now I'm going to use going through 1. I'm going to set my table out with the known facts first of all. So 4 goes to 352. I'm going to go through 1. So write my 1. You should be getting used to this now. So on divide by 4 times by 352. Write that as a machine rule. And for this question, we'll see why this technique is so useful and why I've encouraged you to use it before. We're on divide by 4 times by 352. Okay, that's the time, number of orbits. I feed that in, divide it by 4, times it by 352, and it'll give me the number of days that it will take. So now I apply that to the question given. How many days will it take to orbit the Sun 7 times? So I want 7 divided by 4 times by 352, and put out the number of days. So 7 divided by 4 is 1.75, times that by 352, and it comes out as 616 days. I can now use my little check if I want to use my check. 4 times was 352. 7 times is not quite double. Well, double 352 is going to be 700. 600 is not quite double. I'm fairly happy. I'm likely to be right with that figure there. That's part A done. Now let's have a little look at part B. How many orbits has Mercury completed in 264 days? Now the difference here is that we've got the answer that comes out of the machine, not what we want to put into the machine. However, it's not that hard to change. If we just focus on this bit of the machine, we can write the reverse of that machine underneath here that will unlock the problem for us. So, the opposite of dividing by 4 would be to times by 4. Technically that's called the inverse. The inverse, or if you want to use just normal language, it would be opposite, but I would urge you to using the word inverse of timesing by 352 will be to divide by 352. That's the days at this end of the machine rule, and out here are the number of orbits. So I can now feed in that information. I've been told 264 days, so 264, I'm going to divide it by 352. That's quite nice, isn't it? I think you'll see the pattern of numbers there. Gives me 0.75. And if I times that by 4, I'll end up with 3. So it's 3 days. I could just leave it there, or I could go back and just check. Well, 352 days was 4 times, so 264, it's a bit less, it's a little bit less, and of course I've actually written that wrong now, I apologise for that. It should have been 3 orbits, not 3 days. So we'll make 3 orbits in that time. Hope that's helped. Now there's a similar question for you to have a go at there. Press pause. Okay, welcome back. Here we go. 75 grams of cornflakes provide 270 calories. That there is the fact. Now we have a question. How many calories in 120 grams of cornflakes? And again, we can do that technique of looking for the commonality in the phrasing. Grams of cornflake provide. Grams of cornflake. So it's similar, not quite as apparent as before, because they reversed the question in the sense that we had the cornflakes and the calories. Here we've got the calories and the cornflakes. But the phrasing is still there. Okay. Going to use the technique, going through one. The given information, 75 grams of cornflakes is 270 calories. I'm going to go through 1 to solve this. So I put my 1 there, divide by 75, times by 270. To get from 75 to 1, I divide by 75. To get from 1 to 270, I times by 270. I'm now going to write that as a machine rule. You should be used to this now. And again, it often seems quite laborious, these sort of techniques. And you think, well, I could do them much quicker than this. But actually, part of being good in an exam is not panicking and having some good methods, even habits, to fall back onto. And this is a nice one. It structures your thinking for you and makes sure that you don't make silly mistakes, and also may well get you out of a bit of a panic. Here we go then. Divide by 75 times 270. That's the grams of cornflake going in, and this is telling me the calories coming out. I now apply it to my particular problem, and the question was how many calories in 120 grams of cornflake. So 120 goes in, I need to divide by the 75, and then in a minute I will times by the 270. Let's do that now. 120 divided by 75 equals 1.6, times that by 270, and we get 432 calories. Next bit of the question is here. There are 360 calories in a portion of cornflakes. What weight is this portion? Well, here we're given the end point again that normally comes out of the machine here. So I need to do a reverse machine for that one. And in this case, I'll write it underneath here. So going backwards, we need to do the inverse of times 270. To undo that would be divide by 270. Instead of dividing by 75, to undo dividing by 75, we would times by 75. And now I can fill in my information. I was told it was 360 calories, so it's 360 fed into the machine, divided by 270 is 1.3 recurring. 1.3 recurring times 75 equals 100. So my answer is, it's a portion of 100 grams. I can just go and check that. 75 was 270 calories. 100 was 360. That makes sense. It's actually quite nice, this question. You could have done it without a calculator probably, because 75 is 75% of a whole circle, will be 3/4 of the way around, which is 270 degrees, whereas 100% of a circle would be all the way around, going north all the way around to north, and we've worked that out to be 360 degrees. Quite nice really. We could even use the 120 there as some angle facts. Anyway, not necessary really, because you probably get a calculator for this question. Hope that's been helpful. Off you go, watch another Back of the Net video.